Hello, good noon friends. We continue with the solution of the question paper, and before that let me see some video to discuss to view the basic concepts about orthographic drawings. We solved the question paper of this exam up to the development up to the orthographic projections, and then before that let me see one video to have the basic concepts about orthographic projection. This is the drawing given to us and we have to draw its three views. So for that let me draw axis like this, and here you can draw these lines at any distance to separate the views. This is a meter line. Total width of this front view is known to us 25 plus 70 plus 25. So 125 would be total width. Height would be 25 plus 15. Then draw its center lines, circles over here, and these center lines are drawn at a distance 70 mm to each other, which is given in the data. These are the projection lines from its front view and projection line from the center line. This height is 5 plus 60 plus 5. You can see here this height. In front view its height would appear like this. In top view this is 20, this is 20, which is drawn here, and this space is, this width is drawn here with the full line. These edges are shown with the full line. This dotted line represents this circular hole which is inside. This is radius 20, diameter 24, the circle. Outside circle, this circle is drawn, here is 50 mm diameter. This arc is drawn, and this dotted line shows this bottom edge which is below this cylindrical portion, so shown by the dotted lines over here. Now in top view this is 15 mm. You can see here. If you look from the front side, height is given 15 mm, and here vertical line from this point, this distance is 15, and this thickness is given, that is 5 mm, so represented by this, and this dotted lines shows the circular hole which is drilled over here. Now to draw its side view, let me draw meter line and transfer the points from its top view to meter line to front view, and horizontal lines from all these points on this side. Center line and intersection of these horizontal lines from top view and meter line would be here, and from these points we draw vertical lines as shown here, and intersection of this vertical line and respective horizontal line we can find out position of point. If we look from the right side, these are the points, grid of the points, and after drawing this grid of the point, let me pick up points one by one. The width is 60, so at a distance of 60 draw horizontal line. This thickness is 15, so at a 15, and again 5 mm thickness for this portion. Diameter is 60. This height, these lines shows these edges, 20 mm width, upper and lower. This one 20. Vertical lines on both the side. Again here thickness is known to us, that is 5 mm on this side, 5 on this side. So this is the solution of this orthographic drawing. For three views are drawn over here. Now about projections of solid, how to draw pentagonal prism. Some basic concepts is shown in this video. Let me see that.
Well, let's carry on the discussion of solids. We'll study the case in which a right pentagonal. Well, let's carry on the discussion of the projections of solids. We'll study the case in which a right pentagonal prism is resting on HP with its axis parallel to both HP and VP. As the axis is parallel to both the planes, it does not intersect either of them. However, the projection onto AVP gives true shape and size of the prism. So, we'll draw the side view first, then top and front views by projecting the lines from side view. First, let's generate a pentagon inclined at 30 degrees with XY. This is how the prism will appear from side view. Now, to construct the front view, project the corner points of the pentagon parallel to XY. The prism is resting on HP with its edge A'-P' of length 150 mm coinciding with line XY. Draw vertical lines from points A'-P' above XY to intersect the projectors drawn from the side view at Q', T', R', S' and also at B', E', C' and D'. This completes the front view of the prism. Observe the hidden line E', T' represented as dotted line. Consider a vertical center line MN between the front and the side view. Extend vertical projectors from A' and P' below line XY. Project the corner points from side view onto XY. From these intersecting points on XY, draw lines at 45 degrees to meet line MN. These lines are further extended horizontally parallel to XY, meeting the projectors drawn from front view. Mark the intersecting points as T, S, P, Q, R and E, D, A, B, C. Here, the line AB is hidden. This will form the top view of the prism. Take a look at the entire construction of the prism. Let's crack another construction problem. A regular pentagonal prism of side 60 mm and length 120 mm is resting on HP with its axis inclined at 30 degrees to VP and parallel to HP. So, first draw a reference line XY. Now, first let's assume that axis of the prism is perpendicular to VP and draw the front view with one of its sides lying on XY. Next, for the top view, the projectors are drawn from front view below XY. A horizontal line parallel to XY is drawn to intersect the vertical projectors at points P, Q, T, R, S. Then, at a distance of 120 mm, draw a horizontal line that cuts the vertical projectors at A, B, E, C, D. This develops the prism. Here, observe the lines QB and RC are hidden lines. Now, it's time to create 30 degrees inclination. For that, draw an inclined line at 30 degrees to XY. It represents the axis of the prism. Copy transformed prism from its top view onto this line. So, What will be the front view in this position? It will be formed by projecting the corner points of the inclined top view vertically above the line XY. Then the horizontal lines are produced from the corner points of the previous front view to intersect the above vertical lines. Joining these points in a proper sequence gives the required front view. So friends, in this session we learned how to project solids when their axis is positioned in various orientations with HP and BP.
So we've seen how to draw the pentagonal prism in various positions, in front view, in top view, if its axis makes some angle with HP or VP. Now one more problem about a cone. How to draw projections of solid in case of cone.
Hi, this video is about isometric drawing and the projection of the cone. So this particular cone is sitting in the first angle of the first plane. So I need to draw the first I need to draw the front view plan and the side view, and once I draw that, it says that okay, how the projection look like when you tilt this object at a 30 degree. So this kind of problem are common in the engineering drawing. So first I will draw the projection without this tilt, and then I will draw the projection with the 30 degree of the tilt. Okay, so let's start with, so this is the projection it will look like. So when you look from the top view, you will able to see the circle. Front view will look like a simple triangle, and the right hand side view it will also look like a triangle. The right hand side view is coming from here. So if I draw the arrow, it's coming, right hand side view will come here from this side, and the projection will go here like triangle, and then when you flip the plane, it will go here. Okay, so in the first angle, when you look at when you look at the from the right hand side, the projection will go on the left hand side. Okay, so that's what I have shown here. And now this one is the when you tilt the cone at the 30 degree. So that's what you start with first. So you start this this triangle first, the 30 degree, because that's the one you able to see, and then you extend the lines. So here I have extended lines here at the 45 degree. So those are shown as a dotted line, and you have to also extend the tip of the cone. So when you extend and when this is how the cone will look like from the top view. Okay, so this is the tip, and you able to see this part of the cone, and from the front view you able to see cone like this. You able to see this oval shape and the tip here, and those are coming from this tip will come from here. The width you can extend from the bottom side here. Okay, so this is the isometric projection of the cone with the tilt of 30 degree. Hopefully you like this video. If you like it, subscribe to my channel, and thanks for watching. Bye.
Now next problem about pentagonal pyramid, projections of solid for pentagonal pyramid. How to draw views for the pyramid.
This video is about isometric projection of a pentagon pyramid. So this is the problem statement here, that one side of pentagon pyramid is perpendicular to the vertical plane. So if I go back here, this side that is perpendicular to this, this is a vertical plane here. This side it is perpendicular to the vertical plane. Okay, then draw the projection of this pentagon pyramid in a first angle. So it is in a first angle, so the first part we need to draw the projection based on this shape sitting like this. Okay, if I go back here, after that pentagon pyramid is lifted such a way that it makes 30 degree with the horizontal plane and one side still say perpendicular to horizontal plane. So if you think here, if you hold this tip and lift this pentagon pyramid, then you have to lift such a way from the top that it makes 30 degree from the base and this horizontal plane. Okay, so that's the second part of the problem. Okay, so here let's say if I lift this one and then you lift like this, and then the angle between the base of this pyramid, the pentagon pyramid, and this horizontal plane, that angle is 30 degree. Okay, so that's the second part of the problem. Okay, so this one, it shows in a without lifting the pyramid from the top. So if you look from the top view, you will see this pentagon here, and then you will see the sides here that will represent each facet of this pentagon pyramid. Now when you look from the front view, you able to see this line edge here, so that edge is extended over here and it represent that edge. Another edge you will able to see this one, so that is shown by here, and this is the center here, so that will help you to draw this front view. And the third edge you will be able to see this one where the mouse is here, so that will you will draw this third edge here. Okay, so that's how you draw the front view. Now from the side view here, you are able to see only three sides, this one, second and third. These two, they will be on the back side, so those two sides will be in the dotted.